All right, so welcome to this talk on using MySQL, NoSQL from Wolfram Language. Okay. So the purpose of this talk is to show you what is an entry point with the existing technologies in Mathematica where you can connect to NoSQL. And I know NoSQL usually deals with very large data sets, and here I'm showing you two of those common ones. One is the MongoDB and Neo4j. And the topics that you'll be seeing here, we'll go through what NoSQL means and some of the basics about how MongoDB handles the documents. And then we'll see what's the connection configuration, what are the settings that you need to do from MongoDB and from Mathematica side, and how to create, retrieve, update, and delete documents, and some of the basics of Neo4j and configuring and doing operations on Neo4j. So NoSQL is a new standard for storing data, which does not rely on the SQL standard. And the document could be of any form. It could be like a key-value pair. The data can be stored in a key-value pair. It could be a graph-based database, column, or just a plain document there. And some of the examples are like Cassandra, that's by Apache, and MongoDB and Neo4j. So let's go through the first one here, MongoDB. This is a document-based database. And every document consists of elements which are of the form field and value. And this is stored in the documents in the form of this is a binary JSON format. And the way databases are represented here is that you have an outer collection, which is nothing but a collection of different documents. And each document has a set of elements which are field and then value. Now, if you want to connect to these from Mathematica, so this is basically how you would describe a MongoDB collection. So a collection is a set of documents, and each document contains certain elements with a field and then a value associated with it. So if you want to connect to it from Mathematica with the existing technologies, there's two ways here. Either you can use one of the drivers that come with NoSQL. Many people have made these drivers available free for download. And here I will be using a .NET-based driver and link it through the .NET Link technology in Mathematica. So to get started, first thing you need to do, of course, is to install MongoDB. And here's the download link for that. So when you launch it, you move to the directory where MongoDB is installed. You start a MongoDB server and a client there. And if you're working from within Mathematica, this is the location. If you're working with a Java-based driver, that's the location where you want to store your driver or jar files. And if you're working with .NET Link, that's the location where you would put the driver files. So I'm going to evaluate that, and the path would differ if you're on a different platform. So the first thing that I did, again, was download the driver and place it at those locations in my Mathematica installation directory. The next thing, to connect to MongoDB, just load the .NET Link package that comes with Mathematica, and then start the .NET runtime. Once you get a link object, that means that the runtime is now started. And then I just made a wrapper function around the .NET, the connect function within the MongoDB driver to connect to the database. So I get back a .NET object when I evaluate the connect to MongoDB function, and that means now I'm connected to it. So to show you the set of operations that you can do here, we will first try to create a collection, which we will call a user data. And then we will try to create a few documents, and then insert some elements into those documents and document into the collection. So I have MongoDB running on the side here. So as we do changes from Mathematica, we'll check if those changes are taking effect in the MongoDB actually or not. Okay, so here's some set of functions that I created. This is a function that will create a collection. So let's create a collection named user data. Now, I need a document where I can store my elements. So I have another function that will create document for me. And then I will call that function to create a set of 4 documents there. Now I want to create my elements here, and this will be a field value pair. So I have 3 fields, name, age, and status. And then I insert a few more sets of data in the same document here. So I have my elements ready. And now all I want to do is put those elements into my document. And lastly, when I have my documents ready, I want to insert my document into the collection. So you can see these are all just working on top of the functions that come with the driver. So I've just used Mathematica functions on top of it here. So let's see if my documents are available in the user data. So you can see that if I show all the collections within my database, now user data exists there. And if I want to check if all my documents have been inserted or not. So all my documents are now into the database. OK, so we've done the insertion operation. Now let's get back the data into Mathematica. So here's another function. I want to see how many collections my database contains. So here's another wrapper function. So there's only one collection right now, which is user data that we just created. And here's another get function. So this get function actually gets an enumerator. So I have to loop through every element, apply some kind of a loop structure there to go through each one of the documents and collect the key value pairs. And that's how it works there. So I get all my data here. Now, the good thing about using this data with Mathematica is that Mathematica has this built-in association function, which basically relates a key and value. So here I have my keys, which are name, age, and status, and I can make an association on top of it, and then convert it into a data set. And then once I have the data, all I need to do is query the data set itself to get any specific data that I want. So here I'm getting all the people whose age is about 30 and all the names if I want to. So no more, I don't have to communicate with the database all through here because I have my data set already in the Mathematica kernel. OK, so here's another function. If you want to update some rows of your document, here's another function that we've created. And this function basically takes the connection, the name of the database you want to update, the collection name, a matching field, and a matching value. So wherever you field, it finds a field that matches this value, update the fields with the updated value. So here, in this one, wherever the status is A, update the age to 30. And if I evaluate that, let's check if it has updated. We didn't have, we have one field here, one document here where the age is 30, and that should change. Oh, sorry, we were updating wherever the status is A. So wherever it found the status as A, it has updated the age to 30 there. So so the basis here is that if you have a driver for any .NET or Java, even Python, Python is not actually a supported one, but we do have a Python link that comes with Mathematica. You can make these wrapper functions, put the driver at a certain location that Mathematica can recognize, and make these wrapper functions on top of it and get the data and communicate to and fro with your database. Okay, so the next database that we'll be looking here is Neo4j. This is a graph-based database. So data is represented in terms of nodes here, and the relationships are represented here like as shown in this graph. So each node has some properties here. So here I have name and a person here named John and country USA. And they're related by this knows property. So John knows David, and John knows Johan, and Johan knows David. And Neo4j works on this language called as the cipher language. And if you want to connect, the first thing that you need to do, of course, is to have your Neo4j running. So you can download it. Here's the download link. And I'm using the Neo4j community web server and version 2.1.2. Now, here I'll be using a Java-based driver. When I downloaded this driver, it had a version check within it, which would not allow me to work in a very straight way here with the Mathematica. And so basically what we did was downloaded the driver source, and we changed the code a little bit and recompiled it. And the driver will be available if you want to have this notebook. And this is the one that works perfectly with Mathematica. So once you have Neo4j installed, you can start it, and you get a screen something like that. And I have it running here. And since we'll be using a Java-based driver here, so I will have to first load the JLink package, which comes with Mathematica, and that makes available all the Java functions within Mathematica, and then start the Java runtime. Now, the driver, you have to make the JRE or the Java runtime aware of where the driver is. So there's a function in JLink, which is add to class path. So you point the class path to wherever your driver is using this add to class path function. And then the same way how we did using .NET and MongoDB, we just make this function on top of the connect function that is in the driver here, and do that in Mathematica, and just call that function. Okay, so what this gives back is a Java object. Once you have the Java object available, it means that the connection is established. Now, it's a little easier to work with Java drivers because of the flexibility, and even the documentation is much more clear when you're using the Java driver here. And so I made two functions here. One is execute query. So this will take any queries like create something and execute it. So it doesn't really return back anything much. And the other function is get data. So this will take queries that will actually return some data. So let's go ahead and create a graph here. I'm using directly here the connection object that we got when we connected using the connect function. And then I can directly put the cipher language query in the execute query here. So this is going to create the same graph that you saw before in this first slide here. So if I evaluate that. Okay. Now, we can go back into our Neo4j and see if it has created something. So we have our all the three nodes created here. And now I will run the get data function, which will let me get some data based on whatever criteria I give. So I want to return the node which has the name David there. So it gets all the information about David, and some more functions here. I want to just get the names of these people. So I get all the name here. So I'm just doing order by, so it will order it alphabetically. I want to get the countries. list of countries here. Now, a nice thing that you can do here is to use Mathematica's functionality of graphs. So you can use the graph function in Mathematica and make your own nodes and connect them together. So once I have the data from Neo4j, I can make a graph that looks similar in Neo4j, same in Mathematica. So that's what I'm doing here. So from the data that I have from the graph that we created in Neo4j, so this is what Mathematica gives, and this is the same as what you see in Neo4j. OK, and then if you want to delete something, you can just put your cipher query in execute query. It's going to delete. And if you want to delete all the nodes here, all the nodes are now gone. If you want to check there. So I just deleted everything that we created here.